The American economy relies on an interconnected physical framework to move goods, power factories, and supply water. But when the pressure on that system exceeds its capacity, the resulting friction brings absolutely everything to a halt. By 2021, that friction was quantifiable. The American Society of Civil Engineers projected a nationwide infrastructure investment gap of $5.6 trillion over 2 decades. Congress responded to this deficit with the Infrastructure Investment and Jobs Act and the Inflation Reduction Act. From 2024 to 2026, these authorizations direct $344 billion in new funding towards surface transportation, national energy grids, and water systems. This capital injection successfully stopped the growth of the national investment gap. However, the funding mechanism is temporary. The current authorizations expire in 2026, creating a mathematical split in the nation's economic output through 2043. Analyzing 20 years of data proves that the efficiency of these physical networks determines the total possible output of the national industrial base. To understand how infrastructure acts as a multiplier, we can examine a highly optimized model in practice. The port of Bremerhaven in Germany serves as a benchmark for specialized automotive logistics. This facility operates 18 separate berths along 5 kilometers of quay, allowing it to process over 1.25 million vehicles every year. Managing that volume requires a localized workforce of 38,000 employees, but those jobs are only the primary layer. Bremerhaven operates a gateway function, where localized capital investment generates economic activity far beyond the port itself. By providing manufacturers with efficient access to global markets, this single gateway sustains nearly 344,000 jobs at industrial enterprises across the entire country. When specialized physical infrastructure falls behind demand, this employment multiplier reverses, creating a systemic drag on the national economy. In the United States, the baseline requirements for a functional economy are facing several shifting variables. In surface transit, remote and hybrid work arrangements have shifted the timing and volume of vehicle movement. While peak-hour gridlock has dropped, private car trips are up 15%, increasing vehicle miles traveled and physical wear on highway systems. Simultaneously, transit agencies are operating with ridership at roughly 73% of pre-pandemic levels, leading to severe fare revenue shortfalls. The energy sector requires even larger capital adjustments. Over the next 2 decades, the United States will need a load increase between 6,000 and 10,000 terawatt-hours. Demand is being pushed by industrial electrification and the rapid adoption of electric vehicles. This load increase arrives as solar and wind reach cost parity with gas generation, requiring new transmission infrastructure to integrate these sources into the grid. The water sector is also facing immediate capital needs driven by new regulatory initiatives. Municipalities must finance the treatment of PFAS chemicals and meet a mandated 10-year timeline for replacing all lead service lines. Because these frictions are compounding at the same time, relying on outdated funding levels leads to systemic failure. The ASCE utilized LIFT and Inforum macroeconomic modeling to project the cost of that failure through 2043. Scenario 1 is the snapback. This model assumes funding expires in 2026 and reverts to the deficit levels seen before 2022. The snapback results in longer transit times, lowered grid reliability, and constrained export efficiency at seaports. According to ASCE's economic modeling, the snapback scenario strips $4.4 trillion in gross output from U.S. industries over the next 10 years. This loss leads to a corresponding $2.2 trillion penalty to the gross domestic product. Scenario 2, continuing to act, assumes current spending levels become the permanent new baseline for annual investment. Maintaining this baseline reduces the gross output loss to $3.1 trillion. The GDP penalty also falls to $1.5 trillion. This $700 billion difference proves that capital infrastructure expenditure acts as a direct subsidy for industrial efficiency. These multi-trillion-dollar models translate into tangible stakes for individual American families. When we chart disposable household income over 20 years, the two funding models clearly separate. Continuing to act protects the workforce, saving 237,000 jobs that would otherwise be lost to systemic drag over the next decade. By 2043, this investment baseline saves the average American household nearly $700 in disposable income every year. These savings represent the eliminated cost of friction, car repairs from rough roads, the purchase of bottled water, and losses from spoiled food during power outages. Leaving the investment gap unaddressed forces households and industries to pay for systemic failure through repair bills and lost time. Sustaining the current funding levels is the mathematical prerequisite for a 21st century economy.